the coefficients, and we have to decide, is it easier to eliminate x or is it easier to eliminate y? It's okay if you are wrong. Just
would it be x?
yes. Which one will you multiply and by what?
We multiply 3 by 2.
That, but negative. Because the 6x plus 6x will give us 12x. We don't want 12x. Is it clear why?
Yes, I understand.
Yes, one has to be negative, one has to be positive for the terms to go away when I add them. Good, so negative. And careful, do not multiply just the first term. You have to multiply everything, otherwise you're changing the equation. So negative 6x plus 14y equals negative 26, and 6x plus 5y equals 7. So indeed, we multiplied, we used the prep. What was the prep here? We multiplied the first equation both sides by -2. We prepped the first equation. It's the same. It's equivalent. -2, 6x, positive 14y, and negative 26. It was prepped. We copied the second equation. We drew the line to add, gone. That was the purpose. So now we have 19. Y equals negative 19. So then y equals -1. Nice. Not good enough because I only have the y coordinate. I don't have the x coordinate, but that's no problem. I can go back anywhere, it doesn't matter where. So if I go back here, so I have 3x and plus 7 equals 13. I move 7 to the other side because it will become negative. So then 3x equals 6, so x equals 2. Is it true? I have no clue. But I don't need anybody to tell me anything. So 2, -1, 2, -1. 6 plus 7, -7 times -1. 6 plus 7, yes. 12 minus 5, 7. And then I'll say, indeed, yes. Consistent system, unique solution or one solution or unique solution, independent equations. Any questions? Any questions on the elimination method? Any questions?
I don't have anything.
Okay. Now I also want to talk about some applications, but not before. Not before. I want to choose a problem. I want you to see a problem with no solutions and a problem with infinitely many solutions. And then we choose some other word problems. No, this is 5. Okay, so here's a system. Okay. So let's solve the system by any method you want. You choose the method. Do you want to use substitution? Do you want to use the elimination? What would you like to choose? What
Let's
would
do
you?
substitution.
Okay. Then, not from here, although we can always simplify. Let's use which variable you want to solve for. It doesn't matter.
X.
Okay, so that's negative y plus 3. I have to move y to the other side, negative y plus 3. Therefore, in the second equation, I will replace x by negative y plus 3. So 2, quantity, negative y plus 3 plus 2y equals 12. Distribute, negative 2y plus 6 plus 2y equals 12. I'm telling you that if you have $6 in your pocket, it's the same thing with having $12 in your pocket. What do you think about that statement?
Not false.
Absolutely. That's not possible. So the system is inconsistent. The lines must be parallel. And there are no solutions. I got an inconsistent, I got a false statement. Not acceptable. Okay, very good. I'm going to change the same problem a little bit. Okay. Let's suppose we are using the same method, or let's use elimination this time. Let's eliminate x. So that means that I have to multiply the numerator. Oh, the first equation, not the numerator. The first equation by negative 2. Okay, so negative 2x minus 2y equals negative 6. I copy the second equation. I add. And this is a true statement and true forever. So, which situation is this? Is it the one solution? Is it the no solution? Or is it the infinitely many solutions?
Would it be number 3?
Yes, indeed. Infinitely many solutions. And here's how we write, very interestingly, how we write the solution that incorporates everything. Is there a way? Yes, there is a way. So previously we solved for x. X was negative y plus 3. Okay. So when y is y, x is negative y plus 3. Is there another way of writing it? Yes. When x is x, then I solve for y, so I have negative x plus 3. It doesn't matter how you write it. They both mean the same. What does this mean? Well, if y is 1, x is 2. If y is 0, x is 3. If y is 2, x is 1. And I can go on forever. Infinitely many solutions. For any y I can think of, I will determine an x. Let's say y is negative 2. If y is negative 2, x is 5. Negative 2 plus 3 is 5. If y is 10, then x is negative 7. If y is 20, then x is negative 17. And I can go on forever. The same thing here, it doesn't matter. They're exactly the same. When x is 1, y is negative 2, y is 2. When x is 10, y is negative 7, and so on and so forth. So this is the way you choose one of the variables and put it fixed in there, and then you solve the other variable in terms of the first one. So that's how we present infinitely many solutions. Okay, I wanted to talk about an application here called the break-even point. Break-even point, in short. What does it mean? Well, it involves 3 functions: total cost, total revenue, and total profit. They're labeled as C of X, R of X, and P of X. And there is a relationship among these three. The profit is always the revenue, money coming in, minus the cost. So what is the break-even point? The break-even point is either option 1, profit is 0, or option 2, revenue equals cost to make the profit 0. Revenue equals cost. They both mean the same. So the break-even point is when the company should start making money. In other words, the revenue covers up the costs. So when the revenue equals the cost, we get the break-even point. Or you can say when the profit is 0, then we get the break-even point. The break-even point is a point. X that makes the profit 0 or revenue to be equal to the cost, and the revenue of that X. So this is the break-even point. You have to present it as a point. X is the X coordinate that makes profit 0 or revenue, in other words, equal the cost. And the Y coordinate of the break-even point is this function evaluated at this number. So let's look at some examples. So see how this works. Okay, so let me go to the book. Okay, where's my book? Please don't tell me I'm logged out. Please, please, please. Okay. Okay, page 558. Okay. Describe a number of business ventures for each exercise. So write the cost function, write the revenue function, determine the break-even point, describe what this means. So let's choose. Small canoes, bicycles, play, and greeting cards.
We start with number 61.
Yes, let's start with number 61. A company that manufactures 61 and 558. A company that manufactures small canoes has a fixed cost of $36,000. Okay. The total cost function is a sum of two pieces. The variable cost, which depends on the number of units we manufacture, and the fixed cost, like rent for the building, maybe the custodian, maybe the lights in the offices, the secretary, maybe fixed costs. Here, it depends on the number of units we manufacture. We still have to have somebody opening the door in the morning. That is a fixed cost. That does not depend on the number of units we manufacture and resell. So this is the variable cost. It depends on X. This one does not have X. It does not depend on X. It's fixed. So in this problem, they're telling us that the fixed cost is $36,000. Okay, let's move on. It costs $40 to produce each. So this is the variable. $40 to produce each. If I only manufacture 1, it will cost me 40. If I manufacture 2, it will cost me 80. If I manufacture 3, it will cost me 120, and so on and so forth. So I do have the cost function now. So the total cost will be 40x, which I know is the variable cost, plus 36,000, which is the fixed cost. And this is it for the cost function. The selling price is 160 per unit. Okay. Now we're talking about revenue. So we produced, and now we want to sell. So it says 160 times each unit. And this is the total revenue. The revenue function is 160x. If I sell 1, I get 160. If I sell 2, I get 320. If I sell 3, 480, and so on and so forth. Final question. So we have the cost function, we have the revenue function. Now they want us to determine the break-even point. I'm going to add another question here. And the other question is, find the profit function. By definition, the profit function is the revenue minus the total cost. Be very careful, there is a negative in front, and this has 2 terms. You cannot distribute a negative symbol to the variable and forget about the fixed cost. So the negative symbol has to be distributed to both terms. So I copy the revenue, which is 160x, but minus 40x and minus the fixed cost. Some students subtract the variable, but they add the fixed. No, we cannot add the fixed cost to the revenue. So we have to subtract the variable as well as the fixed. So then the final answer here for the profit is 120x minus 36,000. Now, they're asking us to find the break-even point. So the first option again is either P of x equals 0. The second option, the answer is absolutely the same. It doesn't matter which method we use. Revenue equals cost. The reason why I always like to present or determine the profit, because this is always easier than this, to set this equal to 0. But it doesn't matter, really. It doesn't matter. Which method would you like to go with? It doesn't matter. You're not hurting my feelings. We can go with this. It doesn't really matter. The answer is going to be the same, and I have to go back and check anyway. So, which one?
Can we do the first one?
Okay, I have it right here. So this is 120x minus 36,000 equals 0. Of course, I move 36,000 to the other side. I simplify by 10, and then x equals, when I divide 36 by 12, I get 3 and 2 zeros. So this is the number of units, the number of canoes, the small canoes that has to be produced and sold for the profit to be 0, so that from that moment on, at number 301, we start making profit. So this is what we have to meet first in order to meet the threshold and then move on and make money. This will give exactly the same result. So it's 160x must equal 40x plus 36,000. And it's the same thing. We subtract and we get the same 120x equals 36,000, or x equals 300. The break-even point is a point. This is 300. And this is the revenue at 300. The revenue is 160 times 300. So 160 times 300. So what do I get? 48 and 3 zeros. So the break-even point, what is the explanation again? This is the minimum number of units that have to be manufactured and sold, so that from that moment on, moving up, from there, 301, 302, the company makes profit. Only at this level, the costs are fully covered by the money coming in, by the revenue. From this moment on, they will be making money. They will be making profit. Any questions? Okay. Next question. Anything else?
We try 64.
Okay, very good. Let's look at 64. Let's look at the time. We probably have enough time to finish this one. And that's my page 8. And you said 64. So let's take a look. You invested 7,000 and started a business writing greeting cards. Okay. Supplies cost. So that's that your 7,000 per card. You're selling each card for $2. Okay. When they said invested 7,000 and started a business writing greeting cards, supplies cost this per card, and you are selling each card for $2. So I'm assuming that this 7,000 is the fixed cost. So what is your understanding? Because this is very clear. The cost includes an overhead, which is the fixed cost, plus production cost. So this is very clear here. Here it's not very clear. You invested 7,000. So is this in addition to? This is how I understand it. So the cost function is 20 cents per card plus 7,000. So 7,000 is the fixed cost. And they do have to come up with 25 cents per card that they have to manufacture. And you're selling each card for $2. So then the revenue is 2x. So the 7,000 was the fixed cost, 25 cents per card, and we're selling them for $2 a piece. Very simple to find the profit, 2x, but don't forget to subtract both, minus 0.25x and minus 7,000. And when I combine like terms, I get 1.75x minus 7,000. Subtract 25 cents from $2, 1.75. And the break-even point is when the profit is 0. So I have to set this equal to 0. 1.75x minus 7,000 equals 0. We move and divide by x. To find x, we move and divide by 1.75. So what are we getting? I have the calculator brought up. So 7,000 divided by 1.75, what is it? 4,000. So in order to start making money, they have to produce and sell 4,000 units, 4,000 cards. But the break-even point is a point. So 4,000, comma, the revenue for 4,000, 8,000. Any questions?